first 1,000 square feet of that particular type of development. It's just described as window and no indoor seating. So very generic description. Just by way of reference, if you took if a donut shop or coffee shop were to lease there, 42.93 trips per 1,000 square feet. Far cry. So they don't know the lessees. They choose the generic code. Trips could end up being far worse. Just kind of another defect here. The city says, look, the possible tenants for such a strip can be such stores as phone, restaurant, clothing store. Well, yeah, they could be anything. It's possible. The city is admitting they don't know. No one knows. And so use of a generic code 820 for so many square feet of retail, you're looking at a potential margin of error for generated traffic in huge numbers if the lessees end up being places like donut shops or something like that. The TIA appendix omits data needed to verify results. Wow, this has been very frustrating for all of us. This is an excerpt of one of the exhibits from the TIA. If you look at A there, these are just traffic volumes for the AM peak hour. The engineers assign volumes to each of the turn directions so they can figure out where traffic's going within the hour. Same up there with B. You see that intersection's a two-way meets a one-way, so there's a few less turns that can be made, but they assign the volumes. They use this great computer program called Synchro, which does all the math for them. They just have to kind of input the traffic counts and make the distributions, and then Synchro tells them, delay times and all kinds of different things. Now, we complained that we didn't get the HCM signalized reports, or that those reports weren't included in the appendix to the TIA. When our members of our team, who are traffic engineers, have said it's very easy. You just print out the report, and it's normally in the appendix of any TIA. And while they did give the HCM unsignalized reports, like have been evidenced there on the left, A, they only gave the timings evidence there, B, to the right, for the signalized intersections. Well, the timings don't include all of the volumes, which has meant that we haven't been able to verify a lot of the data. Now, we feel the design manual calls for the HCM signalized data to be included. This particular language here, we feel calls for the inclusion of the HCM signalized data. Analysis models there, you see the language. Here, analysis must utilize the HCM, or control delay calculations, and those methodologies. And then the kicker here, the analysis engineer shall use the methodology of the HCM to complete any capacity analysis. Again, how could he do that if the HCM signalized reports weren't included? And here's the kicker too, via public information request, we got the Silver Road Wal-Mart TIA, which was submitted to the city. They say, check it out, we've got all this stuff attached in Exhibit D, and sure enough, they include their full HCM signalized intersection capacity analysis. We have demanded the documents. The city won't give them over. They're so easy, you just tell the Synchro program to print them, and you can just send them. But the city has said all the information is in the TIA. And it's just flat out not. The HCM signalized Synchro reports needed for outsiders to verify it are just flat out missing. Let's talk about levels of service. The way the engineers track how bad the intersections are is they give it a grade, like in grade school, A through F. You can see there, A is, you don't even notice the traffic, it gets gradually worse. You can read the language there. Look at E and F though, heavy, unstable, no gaps, delays greater than a minute, total breakdown. So remember this, we talked about how they have to do what's the traffic now, what's the traffic going to be right before the project, how's the project going to add to the traffic, what's the traffic going to be like after the project, and do we need to mitigate? Well, how do they determine if they need to mitigate? Well, the city has a way to determine it, and it's in the design manual. Existing traffic, what's the grade? And so you decide up here and you work your way down. Okay? So, for instance, let's take the example of, let's just take a random example. Let's say traffic existing before a big project is D. Let's say the engineers estimate that right before the project is going to be open, traffic will have gotten a lot worse because of a growth rate, for instance. And so now it's an E. Well, then let's say the traffic impact analysis says, well, we've projected that the traffic after the project, which is this category, is going to be an F. Uh-oh. Then the developer is required by the city, after going to the next level, to mitigate back to an E. So you see how the arrow went back to an E. So wish I had a pointer I could follow along, but I think you guys get the point. We'll come back to that as it relates to this project. Okay, wanted to point this out. This is what the levels of service at the different intersections are in the no-build condition. And that is basically the background condition. Okay, and this is with the feeder roads in, but no project yet. So you see there's an F at Yale and Kohler right away because they analyzed it. It's not signalized. And you see there the F, the important F at Yale and I-10 eastbound feeder road. That's important because they determined that even before the project is to go in, those new feeder roads that TxDOT's building makes Yale and I-10 eastbound feeder an F. I mean, that's pretty significant. Wanted to show you this again to point out that the reason that Yale and Kohler Street was a F in the no-build condition, in the background condition here, is because they hadn't yet analyzed it as being a signalized intersection. You see there the number 6. They're going right at that intersection. They're putting up a light. So the important numbers really are here. This analysis compares the no-build or the background levels of service to the build condition levels of service. And you see from this graphic how the traffic is going to be made worse because of the project. So we see there the first category, Yale at IH10, DD, it gets worse. It goes to ED, so that D becomes an E. Then we have FD in the no build, and then after the build, it's just as bad, FD. And you can kind of see the comparisons back and forth. There's one anomaly. You see that one that's in blue, highlighted in blue. That actually got better after the project, which was kind of strange, but I think that can be explained by the fact that they now considered or analyzed Yale and Kohler as being a signalized intersection. Okay, real quick, I want to talk about the mitigations. They proposed, based on how bad the traffic was after the project was built, that there needed to be mitigations done. These mitigations, some of them were already included in the 380 agreement to be reimbursed, some not. Now, what they wanted to do is, A, you see A there, they wanted to build a dedicated right turn lane for people going south on Yale to go right on I-10 westbound feeder. You see B there, they wanted a dedicated turn lane for people going left on the westbound feeder from Heights south. And then you there C, they wanted to add dedicated left turn lanes there for people turning into the project. Those turn lane, if you look around where all those drives are, that's essentially where the Wal-Mart's going to be. So this is very important because this is what the developer's own traffic engineer has said needs to be done in order to make the traffic work around the project. But take a look at this. Even after the mitigation, which is on the right, and compared to the project conditions, but without mitigation, you see that the mitigation they've even recommended does hardly anything to improve the traffic. You go from ED there